All right, so this week we're going to start looking at solving systems. Okay, solving systems is something we're probably going to spend a good few weeks on. Okay, we're going to spend a while in this chapter, so this is just the first section of solving systems. All right, so first thing I want to just make sure everyone understands is what the title means. Okay, what is a system of equations? Okay, well, the kind of problems we've solved before usually had one letter in them. Okay, when you did like, I think it was chapter 3 at the beginning of the year, we might have had something like 2x plus 3 equals, I don't know, 11. Okay, and we'd solve this equation. One equation, one letter. Okay, now what we're going to do is look at solving a system. Okay, what a system is we're going to have two equations, and we're going to solve for two letters. Okay, so that's what this means. Okay, so I think on your notes there's a spot that says which means. Okay. So the trick when you're solving a system of equations is you get two answers. Usually, at least I think today, the letters we're going to use are x and y. Okay? So when you're done, you're going to have x equals, you're going to have an answer. You're going to have y equals, and you're going to have an answer. Okay, so everyone understand the difference between what we're doing now and what we did before? Okay, now you're solving for two letters. Before, you were just solving for one.
And guys, on your sheet, you have like four lines. You're going to fill it in with, it says A, and you write in each thing, system of linear equations. Right? So fill in each blank with those 4 words. And then where it says which means, each equation has 2 variables. You're going to write that in next to the little dash. So fill in those blanks with a system of linear equations. And then next to the dash, you're going to write each equation has 2 variables.
Okay, when we solve systems, there's many ways to do it. Okay, there's even more than the ways we're going to cover. But the 3 ways we're going to cover, one of them is graphical. 2 of them are algebraic. Okay, today we're going to look at the graphical way to do it. Okay, which method you use to solve systems, it really depends on how the problem is set up. Okay, it's kind of like, using the right tool for the right kind of thing. Okay, if I said to you, well, I have to cut something. What should I use? Well, it depends what you got to cut. If it's a piece of paper, I'd use scissors. If it's a tree, I'd use a chainsaw. All right? So when you're solving a system, we're going to use the method that's usually the easiest to use. Okay? And here's kind of the big idea of what we're doing. We're going to graph a line. We're going to graph another line. And we're going to see where they cross. That's it. I'm going to graph a line, graph another line, and see where they cross. Okay, so that's how you solve a system. Just see where 2 lines cross each other. Okay? The only downside to doing it that way is it means you have to graph it very accurately. You can't kind of draw your lines squiggled. You really need a ruler or use your ID and draw it as accurate as you can. Okay, so these steps that we're going to go through, these are the steps to graph, and Mr. Roy kind of went over them in the warm-up, touched on them a little bit. Okay, anytime you want to graph, make sure both equations are in y equals mx plus b. Okay, we'll start out with some that are, and then we'll do some that aren't. But if y isn't by itself, y has to be by itself. Okay, once you get y by itself, you're going to graph both of them. And then we're going to try to see where they cross. we need anything here, Mr. Ray?
Oh, y-intercept.
Oh, y-intercept. Gotcha. Thank you. I wasn't thinking. Okay, so when you graph, there's really two important things you need. You need your y-intercept, and you need your, what's the other thing that's about, we really need to know? Slope. Okay? So your y-intercept, that's when we graph. We start there on the y-axis. And then after we graph the y-intercept, we use the slope. And remember, the slope is usually a fraction. It's rise over run. And we've had the rules for this. If rise is positive, which way do you go? Up. What about if rise is negative? Down. Good. What if run is positive? Right? And if run is negative? Left. Okay. These lines are going to cross at a certain spot. Wherever they cross, that's the answer. Okay, now I know a couple people in here have a calculator, excuse me, like this. We're not going to be using this, but if you do, you could check your homework on it. Like if you had a line like, let's just say 2x plus 1, negative 3x. Okay, I just made up two lines. And I hit graph. Okay, it's going to graph each line for me. Takes a second. And it'll tell me exactly where they cross. Okay? I can calculate where these two lines intersect. Okay? And notice here, you probably can't see it, but the answer here is pretty messy. Negative 0.2 and 0.6. Okay? What I'm trying to show you is a lot of times when you graph, the answer can come out messy. The problems that we give you guys, we're going to make the answers come out nice. Okay? You're going to get nice whole numbers or integers. Okay? Decimals are way, way too hard to get using this method. Using a calculator, this method works fine. But it's way too hard to use this method with decimals. So that's one downside of graphing. Okay? We're not going to use it with decimals. Okay, does everybody have these steps?
No.
Okay. All right, so as we go through, let's follow these steps and try to solve this system. Okay, remember, when we're done, how many answers are we looking for?
How many numbers should we have?
Yep, 2. We're going to have x equals, y equals. Okay, and when I'm done, I'll put my answers right there.
You guys, that little chart that's on the front part of your notes, we're going to come back to that after we go through all the examples. So this example is on the back side of your notes, on that first page of notes you have.
Right, let's start with the first one. Who can tell me how I graph y equals x minus 1? What's first thing I do? Yep.
Put a dot on -1 on the x-axis.
Perfect. Put a dot on -1. And now there's no slope here, so whenever there's no number in front of x, what do we assume it is? Yep. 1. Okay, my slope is 1 over 1. Positive. Okay, so now who can tell me, starting from my y-intercept and using my slope, where do I go to get another dot? Do I go up? Do I go down? Do I go left? Yep. Right one and up one. Yeah. Rise is positive, run is positive, up one, right one. Can I do it again if I want? Yeah, I'm going to do it a couple times just because graphing, I need to be very, very precise. Okay, if I'm off a little bit, it doesn't work. So I'm going to draw my line. see, about like that maybe? Okay, any questions on that? Okay, so there's one line. And now my other line, choose a different color. I'm going to start by going up 3. And what's my slope this time? Ryan, what's my slope here? What number is in front of x? -1, good. So this, since it's negative, I'm not going to go up. I'm going to go down. Go down and to the right. Down and to the right. Now, I think I've actually already found where these cross. Okay? Sometimes that happens. When you're drawing before you even draw your line, you already know the answer. Okay? But I'm still going to draw my line. Okay, and I'll put that one in red. And now, anybody think they can tell me the coordinate where those cross? Yep.
Your markers aren't in the right slots and it's bugging me.
Yeah, where do those cross?
They cross at 2, 1.
2, 1.
Thank you. Sorry.
Yeah. Which one is x and which one is y here?
2 is X, 1 is Y.
And 1 is y. So x is 2, y is 1. Okay? And I'm not going to do this for all problems, but let me fill those in and show you what happens. Okay, the first one was y equals x minus 1. Okay, somebody remind me, what did we get for y?
What number?
1.
1. What did we get for x? Does 2 minus 1 give you 1? Yeah. So what that means is the numbers we picked work in the first equation, and let's check the second one. Y equals negative x plus 3. Okay, what did we get for y? 1. What did we get for x? 2. Is negative 2 plus 3 equal to 1? Yes. So what we just found was a value for x and a value for y that not only worked in the first equation, but it also worked in the second. Okay? If you just gave me this first one, y equals x minus 1, I could give you a million points that work. Okay? 7, 8. 8 minus 1 is 7. 10, 11. 13, 14. 15, 16. Any of those numbers would work in the first equation, but the trick is they have to work in the second one too. Okay? So we found an answer that works for both, and that is the only answer that is correct. Okay? Okay, so again, you don't have to check your answer. I'm just showing you because I think in the next section we'll get into plugging things in, so that's going to come up. All right, this one, I like part of it, but which equation here do you think I don't like the way it's written? Something here Mr. Roy talked about we need to do. Yeah? Yeah, the second one. The second one I don't like because y is not by itself. Can someone tell me how we would move this 3x to the other side? Yep. We're going to subtract it. Okay, this is all stuff we've done before. We've gotten y by itself. It's just now we're graphing 2 lines instead of 1. It's the only difference. Okay, and when I subtract it, do we put the x before the number? Or am I going to put this negative 3x after the number? Think about how it should look. Does the thing with the x come before b or after b? Before b. So I'm going to write negative 3x plus 4. Okay, I'll graph the first one, and then you guys can help me graph the second one. It says my y-intercept is negative 1. So I go down 1. My slope is a positive 2. Positive means up. Up how many? 2. Up 2, right 1. Up 2, right 1. Okay, I'm just going to do it a couple times because I need to be pretty accurate here. Okay, and draw my line. Okay, I think that should be good enough. Okay, if it looks close to the answer and I'm a little off, that's okay. All right, and my second one. Who can tell me what I have to do to graph this one? Oh, Zach? Can you tell me how I'd graph y equals negative 3x plus 4? Good. Put a dot up 4. And then where do I go from there? Down 3, and then right 1. Look at that. I think we already found where they cross. Down 3, right 1. That's where they cross. It doesn't always happen, but it's nice when it does. Okay, since I already know where they cross, I'm not as worried about how careful I am with the second line, because I already have my answer. Okay, who can tell me what the answer is there? Where do they cross? Rose? X is 1, Y is 1. Yep. You could plug them back in and check them, but we're not going to do that this time. Okay, if you graphed it and you got something like, let's say you got this, it was a little bit off, I would say the answer is 1, 1. It's probably because your graph is just a little off. But you're not going to lose any points for that. Okay, questions on that one? Okay. All right, so I said to you that the solution here is where two lines cross. Okay, and I'm going to throw this idea of parallel at you and see if we can connect them. Okay, lines are parallel if they have the same slope and different y-intercepts. So what do you think would happen if I try to solve a system and I draw two lines that are parallel? And remember, the answer is where they cross. Yeah? There'd be no solution. Excellent. Okay? So what does this mean if we try to find where parallel lines cross and they don't? It means we don't have a solution. Okay, and that's possible. It is possible you solve a system and there's no solution. Mr. Ray and I wouldn't give you very many of those because we want to test if you can actually do a problem. This doesn't test if you know how to do it. Okay?
So those numbers that are the same, right? What would they have attached to them? What letter would they have attached to tell you that they're sloped? Ryan? Raise your hand. Raise your hand. All right. What number would be attached? I mean, what letter would be attached to that number to let you know that it's the slope? Yeah, the x is going to be attached. So once it's in slope intercept, if the number with x is exactly the same, that means you have no solution.
Okay, so before I even start to graph this, does anybody have any thoughts? I'll graph this one quickly, but think about what Mr. Roy just said. Look at the number with x. What do you notice?
It's 2 for both of them.
It's 2 for both of them. And what do you notice about the y-intercept? Same or different? Same slope, different y-intercept. Same slope, different y-intercept means parallel. Are these lines going to cross if I draw them? No. So I already know it's going to be no solution. Okay? But let me sketch them very quickly, and I'll show you they're parallel. Start by going up 4. And then from there, up 2, right 1. Up 2, right 1. Up 2, right 1. I'll draw my line in a second. Start by going down 3. Slope, up 2, right 1. Up 2, right 1. Up 2, right 1. You can probably just see from the dots, once I draw my lines, they're not going to cross. Maybe about like that. And there's that one. Okay, so they don't cross. So would we say the answer is? No solution. Okay, so there might be a question on the test that says, just tell me here, is there a solution? Yes or no? Don't find it, just tell me, yes or no. You could say no just by knowing they're parallel. Don't even need to graph. If you want to graph, you can. Okay, here's another idea. We're going to connect this idea. If 2 lines have the same slope and the same y-intercept, then they're the same line. They're the same thing. It's like graphing one line right on top. It's like a red line right on top of a blue line. Same line. So what do you think that would mean? If you graph a red line on top of a blue line, right on top of each other, and I said to you, the solution is where they cross. This is kind of the opposite of parallel. Instead of no solution, what do you think we'd get? Infinite solutions. Okay? So now you guys know the 3 cases you can have, and we're going to fill in that chart in a second. We've seen ideas with this, like on a number line, when we shade all real numbers. That's in 1 dimension. This is kind of like the same thing. Infinite solutions. Okay? If you graph 2 lines right on top of each other, they cross everywhere. Does that make sense? Does that seem okay, Victor? Okay. And Mr. Ware, they already had this all written. They just had to fill that in?
I didn't put that on there,
Okay.
but they have the examples.
All right. This one, not quite as quick as the last one. Okay, I like the first equation. What do you think I don't like about the second one? Ariana? Yeah. So what would be the first thing you'd do to try to get this in y equals mx plus b? What's the first thing you'd move to the other side? And the thing with it too, right? So how would you move a negative 6x? You'd add it. Good. Okay, just like we said before, always keep the number with x in front. So I've got 2y. I'm going to have a positive 6x and a positive 4. Y's almost by itself. Gabe, what's the one other thing I got to get rid of that's next to y? Good. How do you get rid of times 2?
You divide each two
Perfect. By?
by 2.
By 2. Kevin, what's 6 divided by 2? What's 6 divided by 2? 3. And 4 divided by 2, Victor? 2. What do you notice about my second equation and my first equation? They have the same slope and the same y-intercept. So let's graph them. Okay, I need to go up 2, put a dot. Davin, what's my slope here?
3.
3. If you want, we can put it over 1. Do I go up 3 or down 3?
Down.
So that's a negative? No. So we want to go
Up 3.
up because it's positive. And right 1. Okay, up 3, right 1. Okay, so here's my first line. Okay, and I'll do this one, just leave it black. Okay, my second line I'm going to do in red. And they're exactly the same line. They're right on top of each other. So where do these two lines cross? Count? Everywhere. So how many solutions do we have? Yeah, we have infinite solutions. Okay, they cross everywhere. So there's infinite solutions. All right, so I want you guys to turn back to the front page of your notes. Okay, flip back to the front. And you can determine how many solutions a problem has very quickly. Okay, not necessarily what the solution is, but just how many. Okay, so there's 3 things we're going to fill in. Mr. Ray, they just from the chart down, right? Or do they have room for up above?
Yeah, they're just gonna write it, they're gonna write it, they have type of slope, number of solutions in the picture, they just have to write in the rest of it.
So we're going to find out how many solutions a system has just by looking at 2 things, the slope and the y-intercept. Okay, so here's your cases. Different slopes. Okay? Think about if I drew one line and another line, and they had different slopes. How many places would they cross? 2 lines that have different slopes. Kayla? Yeah, they would only cross once. Okay? So they'd make kind of like an X shape. Okay? 2 lines with different slopes will always cross in one spot. Okay? What happens if I had 2 lines that have the same slope, but the y-intercept is different? No solution because how come? What are my lines in that case? Remember what that's called? Remember what that's called? Because they have the same slope and different y-intercept, my lines are parallel. Good. Okay, so same slope, different y-intercept. That's parallel lines. They never cross. No solution. Okay, and then the last example we did, same slope, same intercept. They're the same line. Okay, but how many times do the 2 lines that are the same cross? Yeah, infinitely many. And it's hard to draw that one, but I tried to show you it's 2 lines just right on top of each other. Okay, so in this problem, all they're asking you for is the number of solutions. We don't want you to solve this. We just want to know, is it going to be 1 solution, no solution, or infinite solutions?
No solution.
Why do you say no solution?
Because they have the same slope of x and y intercept.
Perfect. I'm going to write that down. Same slope. Okay. Just circle those. Different y-intercepts. So what I do is go look that up in my chart. Same slope, different y-intercept. The chart says no solutions, because if you drew them, they're parallel. That's it. No solution. Okay. Any question why this one was no solution? You don't even have to draw it. All right, I think we have another one of those. Again, just determine the number. Okay, this one is a special case. Y equals 7. That's a horizontal line. Okay. What's the slope of a horizontal line if it's perfectly flat? Does anybody remember that? What's the slope of a horizontal line? It's not going up. Nope, it's a number. 0. Okay. Somebody tell me, what's the slope of my second equation? The slope is 3. Okay? Y equals, that's a special case. That's a horizontal line. Horizontal line has a slope of 0. The second equation has a slope of 3. Are these slopes the same or different? They're different. Okay? One of them has a slope of 0. One of them has a slope of 3. How many solutions do we get when our slopes are different? Michaela? 1. Okay. Whenever the slopes are different, we get 1 solution.
So there's a couple practice ones on there too.
All right, so we'll give you guys a couple practice ones to do. The homework tonight is going to be a worksheet on 12.1. Okay, make sure you remember your special cases like that last one. Okay,
There's one on there.
and we'll practice a couple of those right now.